Hello and welcome to my channel. This is Obro. Today we are going to discuss a new topic regarding the refrigeration system. So refrigeration system, refrigerator is being used in the home appliances as a home appliances to store the food materials so that the food can be kept cool irrespective of the outside heat. So what happens in the refrigeration system? The heat is being absorbed from the material and it is evolved outside so that the items or the food items inside the refrigeration stays cool. So we see that the gas is converted into liquid, means the heat is being absorbed from the gas, it converts into liquid. Again, the heat is being absorbed from the liquid, it condenses into a solid named ice. So that happens inside the refrigeration where the heat is being transferred. The heat transfer takes place or the thermodynamic cycle takes place where the heat is being absorbed from the substance and it is evolved or it is thrown out into the atmosphere. So here I will show one numericals regarding a refrigeration system, that is a refrigerator operating between 5 degrees Celsius and 27 degrees Celsius has a capacity of 800 ton. So determine the mass rate of the ice formation considering the water being supplied at atmospheric temperature of 27 degrees Celsius. Also find the minimum horsepower required. So consider the refrigerator to work upon reverse Carnot cycle. Latent heat of for ice formation from water may be taken as 335 kilojoule per kg. So here we have that outside air temperature is taken as 27 degree Celsius. So here due to the less space I will make here. This is 5 degrees Celsius and this is the refrigerator, and then it is this is nothing but it is 27 degrees Celsius is outside, and this is the work done W. So this is the temperature maintained inside the refrigerator, and this is the outside air temperature, and this is the work done by the this thermodynamic cycle to maintain the equipment inside the refrigerator to maintain 5 degrees Celsius. How much how much work is to be done to maintain the temperature of 27 degrees Celsius to 5 degrees Celsius. So here we will first calculate the refrigerator capacity, that is 800 ton is already given, and this we are multiplying by 3.5. So we are getting as a refrigeration capacity as 2800 kilojoule per second. So this is the heat extraction rate. So this much heat rate it will be extracted inside the refrigeration system to maintain the temperature of minus 5 degrees Celsius inside the refrigerator. So now the ice formation rate will be the mkg per second. So heat to be removed from per kg of water for its transformation into ice. So we know that heat, we know the formula, that is m into cp into del T. Del T is nothing but temperature, and other is the latent heat of formation. This is the latent heat of formation. I'll write in a short form HCF, latent heat of formation. So mcp del T, cp is nothing but 4.18, and the difference of the temperature is del T, that is 27 degrees Celsius. So we know that at 0 degrees Celsius the water can condense into ice at 0 degrees Celsius. So we are at first we are taking as del T means T2 minus T1, we are taking T2 as 27 degree and T1 we are taking as 0 degrees Celsius, plus 335 kilojoule is the latent heat for the ice formation. So if we multiply, Cp is 4.18, we are neglecting M. So 4.18 into 27 minus 0 plus 335, that is kilojoule per heat. So if we calculate, we will get as 447.86 kilojoule per kg. This is the heat to be removed from per kg of water for its transformation into ice. That is mcp into del T. Del T is the change in temperature, and Cp, that is the constant value 4.18, plus we are adding, that is the latent heat for the ice formation. This is the latent heat we have to add. So we are getting as the heat removed from per kg of the water for its ice formation. that is 447.86 kilojoule per kg. Now, so we have to find what is the ice formation rate. Ice formation rate formula is the refrigeration capacity divided by the heat removed for getting per kg of ice. So this much is the heat required to be removed from the water to transform that water into ice. So refrigeration capacity we have already calculated 2800 kilojoule per second. We'll put over here, and heat removed for getting per kg of ice, that we have already calculated here, MCP del T plus this latent heat, that is 447.86 kilojoule per kg. So if we divide, we'll get 6.25 kilojoule per second, that is the mass rate of ice formation. So now we will calculate COP, means coefficient of performance of a refrigerator, that is T1 divided by T2 minus T1, that is also equal to refrigeration capacity divided by work done. What is the work done or the work required to convert the water into ice, or convert so that the water can solidify into ice. So here we have the two temperatures given here, 5 degrees Celsius and 27 degrees Celsius. We have to convert it to Kelvin, that we have to add with 273 to make it Kelvin. So T1 becomes 268 Kelvin, T2 becomes 300 Kelvin. So we'll just put the value T1 268, T2 minus T1 means 300 minus 268 is equal to refrigeration capacity, we know 2800, we have calculated over here, and this is the work done. So if we calculate this 268 divided by 32, this will be 32 is equal to 2800 divided by work done. So the work done will be 334.33 kilojoule per second. So we have to convert it into HP, means horsepower. So to convert the kilojoule per second to horsepower, we have to divide by 0.7457. So if we divide this 334.33 divided by 0.7457, we'll get the horsepower as 448.34 horsepower. So I hope you have understood how it works, how we have calculated the coefficient of performance, how we have calculated the refrigeration capacity, and how we have calculated the this heat removed required, means heat is removed, amount of heat removed from the water for the ice formation. So this is the way we have calculated MCP del T, ice formation rate, and coefficient of performance, and how we have converted the kilojoule per second into kilojoule per second to horsepower. So this is one of the very important topic of the engineering part of mechanical, that is 11 electrical, energy, power engineering, power management, and power means subjects. So I can see this is one of the very important topic. I hope you have understood, and if any numerical comes from the refrigeration system, the all the these formulas will remain same, only the values will change. So I will end my video over here. Thank you very much.